So let's learn how to compute an antiderivative for the family of trigonometric integrals in this kind, product of sine cosine with powers. Okay, so let's discover how we will do it through some examples. So the first example, here it is. So example 1. So I want to find an antiderivative of cosine x power 3 dx. So let's follow the idea. An idea developed is to isolate one cosine. So I will have cosine x left square and isolate cosine x dx. Then, so isolate we say isolate or save one cosine, isolate one cosine. Okay, then second step, so this is so maybe I should use another color to write it here. So let's write here the comment we did. Okay, so it's save one cosine factor. Okay, save one cosine factor. Then look what we will do. Then here I will use the rule sine square plus cosine square equal 1. Okay, so I will have something like that, cosine x dx. So here is what I did here. So use substitute cosine x square by the expression 1 minus sine x square. Okay, then let's continue. Then we will use substitution here. Okay, use substitution. Here is the substitution. Use substitution. Which substitution? It's clear. It's u equal sine x. Okay, then du will be cosine x dx. So we will get then 1 minus u2 du, from which we can compute easily find our antiderivative. So antiderivative is u minus u3 over 3 plus a constant, which is u is cosine x minus 1 over 3 cosine x power 3 plus a constant. Okay, let's now do another example. Okay, here is a second example. Okay, is about finding the antiderivative of the following: sine. Okay, so sine x power 5 and cosine x power 2. Okay, cosine x dx. Okay, so here is how we will proceed. Okay, so let's try to do as previous case. This time I will isolate one sine factor, cosine factor. Okay, so I will write then sine, so I will have sine x power 4 left, cosine x square, and then sine x here. So let's write what we did here as operation. So save one factor, one sine factor, Then let's continue. Then we will use we will substitute sine square by this term. Use sine x square equal 1 minus cosine x square. You see how? Why? So you will have here, I have then it's 1 minus cosine x square cosine x square and sine x dx. And now I see that I can use a substitution. Substitution here. Substitution u equal cosine x. Okay. Then so I will get then 1 minus u2 square u2, and du is minus sine x, so it will be minus sine minus u. Okay, minus u du. Okay. Okay, so maybe to see it well, du is minus sine x dx. So I did a mistake here. So let's erase this part. So I have then minus du. Okay. So yes, I did a mistake. So it's minus 1 du. And here, of course, it's easy to find the derivative. It's polynomial. So I just need to develop my polynomial. So I will get here, it's minus so u2 times 1 plus u4 minus the double product du. So it's in minus u2 minus 2 plus 2u4 and minus u6 du, which gives us minus u3 over 3 plus 2u5 over 5 minus u7 over 7 plus a constant. Then come back to the original variable. Okay, so we will get then minus 1 over 3. So our u was cosine x, so cosine x power 3 plus 2 over 5 cosine, is it cosine? Yes, cosine x. So here I think I did mistake here for this example. The substitution was sine x, so let's correct here. I did a mistake here. So sine x here, okay? Sine x, okay? So I did a mistake. Now let's come back here. It's cosine x power 5 and finally cosine x power 7 over 7 plus a constant. Okay, great. So now another situation now. So another situation is the following. The third situation is the following. So let's see it through the example, following example. Let's use the color blue. It's blue color. Okay. So so we are required to find this time the following antiderivative. So this time we have to look for the following. Okay, so what if we had an antiderivative of sine x squared, simplest one. So this time isolating sine x will not help. Using just the formula sine squared is 1 minus cosine squared will not help also. The idea here is to linearize the term. So we will use the following formula. So use sine x squared, okay, is equal to 1 minus cosine double the angle over 2. So linearization, we call it linearization. Okay, so here it is. So we will have then 1 minus cosine 2x, okay, dx, and we have factor 1 over 2. And here it's easy, we can use substitution then. Okay, so we know an antiderivative easily, x 1 over 2, so we will have x and 1 over 2 sine 2x using, so we can use here, we can deduce this using small simple substitution of u equal to x. Okay, okay, so here it is plus a constant, and we can see it again through the following example also. Okay, maybe I can find something else. Okay, another example is the following. So sine x power 4 dx. Here again, so we have we will use the same transformation, so it will be half 1 minus cosine 2x everything square. Okay, dx. Okay, and then we develop, so we will have what we will have then 1 over 4 1 minus double product plus cosine 2x square. Again, for the first first two terms we can see easily an antiderivative, but this one it's a cosine of an angle square, so we cannot isolate, no transformation is helpful. We will use again here, we will use linearization, so I will write it here maybe, but let's use the first linearization. So I will have 1 over 4 1 minus 2 cosine 2x plus here linearization of cosine of an angle square is 1 plus cosine double of the angle, which gives me 4x. Okay, dx. So use cosine theta, use cosine theta square equal 1 plus cosine double the angle over 2. Okay, so yes, and then yes, and then it's easy to find, so let's write it just bigger here. So we will have x minus 2, so sine 2x half cosine, yes, then plus half of x and plus 1 over 4 sine of 4x. Okay, if you derive cosine 4x, okay, plus a constant, you see. So this is, and this works, and this method will work always. So we have three situations here, three situations, either n, so it works, so let's n here, for example, n is odd, this is n is odd, we are in the case where n is odd. Okay, so n is odd, n is odd. This is how we proceed when m, the power m is odd also, so either n or m is odd, we can do that. Okay, m is odd, so we can proceed also like that similarly. Okay, so it didn't work, let's redo it. No, it didn't work. Okay, it's okay. And then the situation when we have n and m are simultaneously even, n and m even. Okay, n and m even. Okay, then use linearization. This is what we call linearization. maybe that. Okay, linearization. So this is how, and there are plenty of course situations for integrating trigonometric integrals, but let's say we will stop here for okay, for simplifying. You can explore other situations, other substitutions, particular substitutions, etc. Okay.